Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and this is the first video in a series of videos on solving word problems. In all of my years of teaching, the one area of mathematics that has probably garnered the most complaints and has triggered the most math anxiety is word problems. And there's a reason that word problems is difficult or more challenging for students. Actually, there's a number of reasons. One reason is that it's like a new language. When you're dealing with word problems, you're taking English words and trying to convert them to mathematical operations and equations. Secondly, there's a lot of different ways, types of word problems, and they don't all have the same approach. You don't solve word problems the same way. There's different ways that you do different problems. And that's the other thing with word problems. I think the reason that they're difficult is because students have to be risk takers when they're solving them. It's not like you can plug into a certain formula or a certain method of solving that always works. You have to try things that may or may not work. So don't be afraid of them. I'm going to try to help you out as much as I can. I'm going to start by talking about some of the vocabulary or terminology that you'll see in word problems and help you translate it into math. And then we'll start looking at, in this video, word problems where the relationship is defined in the words. So let's start with the terminology. If you see the word sum or more or increase or greater, they all mean the same thing. They all mean the operation of addition. So the sum of two numbers, if something is so much more, it means addition. If you increase something, you add. If it's so much greater, it's addition. Similarly, difference, less, decrease, and diminish all represent, or words that mean subtraction. That's the mathematical operation you're going to use when you see those words. If you see the word product, the word of, the word times, those mean multiplication. Sometimes people have trouble with the word of, but if you think of finding 2/3 of something, it means multiplication. You multiply 2/3 times whatever it is you're finding 2/3 of. Quotient, ratio, those represent division. And there's more. If you see the words is, result, was, the same as, gives, makes, leaves, will be, equals, or is equal to, all of those words can be interpreted to mean equal. Then you're also going to see some other terminology like consecutive numbers. So I want to describe or explain what those are and how you deal with them. Consecutive numbers just mean one number, whole number, then the next whole number, and then the next whole number. So if I started off with 8, the next consecutive number would be 9, and the next consecutive number would be 10. Consecutive, even consecutive numbers, or consecutive even numbers, would be, let's say we started with 6. The next consecutive even number would be 8, and the next one would be 10. Consecutive odd numbers, if we started with, let's say, 11, the next one would be the next odd number, which is 13, and the next odd one is 15. What I want you to understand with consecutive numbers is that if you start with this one, if you don't know what it is and you call it n, we can describe the next consecutive number in terms of n. It will be one more. Then the next one will be 2 more than this. It's 1 more than the second one, but 2 more than our first one. So it will be n plus 2. Similarly, with consecutive even numbers, if your first number is n, the next number will be n plus 2, and the next number will be n plus 4. Same thing with consecutive odd numbers, n plus 2, 13 is 2 more than 11, 15 is 2 more than 13, which is 2 more than 11, so it's 4 more than 11. So let's get started. I think the best thing to explain how you interpret words into mathematical equations is just to look at some examples. So let's get started with that. In our first example, it asks us, it says 5 less than 4 times a number is 19. What is the number? So it's telling us the relationship in the words. I don't need any other prior knowledge. I don't need any other mathematical relationships. I just use this. So when you're solving a word problem, you have to determine what your unknown is going to be. And typically you want to make it whatever it is the problem is asking. In this example, it's asking for the number. I'm going to use the letter N because it's easy to represent number with the letter N. And I often suggest to students doing that. If they're finding a velocity, call it V. If they're finding time, call it T, and so on. So I define my unknown with a little statement, let N equal the number. It's pretty straightforward. I don't need to describe it any more than that. There are no units because it's just a number, but if I had units, I would include those. If there are any other unknowns in the problem, I would try to describe those in terms of my this unknown. There isn't in this case. Now I can just go to the words and try to, obtain an equation from those words. So 5 less than 4 times a number. Well, let's start with the 4 times a number. That would be 4n. 5 less means we subtract 5 from it. So that's 5 less than 4 times a number. That means equals 19. Once you have the equation, the rest is usually a lot easier. It's getting this equation. That's the tricky part. Now we just solve. We're going to add 5 to both sides. So 4n will equal 24. Now I'm going to divide by 4. And my answer is 6. When you get a result, often you'll be required to put that result, first of all, check that you've answered what the problem asked, and then you'll be asked to put that in a sentence form where you answer the question. So we would say the number is 6. Now, before I finish this, what I would probably do first is I would check this. So I'd go, does 4 times this minus 5 equal 19? I would do a quick check because you can easily see, or usually you can easily see if your answer is correct. It is, 4 times 20, or 4 times 6 is 24. 5 less than that is 19, so we know that we've done it correctly. So there's my statement. The number is 6. Let's try another one. In this next example, it says the sum of 3 consecutive numbers is 36. Find the numbers. So we actually have 3 unknowns in this problem, but we can't have 3 unknowns in our equation or we won't be able to solve it. We only want 1 unknown. So what we want to do is define what our unknown is going to represent, and then we're going to try to represent those other 2 numbers in terms of that variable. So again, I'm going to use n as my variable, and I'm going to let it represent the first number. So let n equal the first number. So then the next number will be n plus 1. So n plus 1 will equal the second number. And I know that this is kind of time consuming and possibly tedious, but if you start writing these things down, then you don't have to keep going back to your words. You've got this to refer to. And as your problems get more complicated, getting in the habit of getting all of the information down in a nice, neat way and defining all of your unknowns in terms of your one variable, it will make it easier for you. So we've got one more, we've got a third number, and it will be 1 more than this, or 2 more than that, so n plus 2 will equal the third number. So we have 3 numbers we don't know, but now we can look at the problem and go to the words and make an equation out of the words. It says the sum, so sum means addition, of our 3 consecutive numbers. So how do we express sum? We add, so n plus 1 plus n plus 2 So that is the sum of the three numbers right there. Is equals 36. There's our equation. Now we're going to solve it. N plus n plus n is 3n. 1 plus 2 is 3. Equals 36. Subtract a 3 from both sides. Divide by 3. So my first number should be 11. The second number, so if that's 11, the second number should be 12, and the third number should be 13. Let's add this up. 1 plus 2 plus 3 is 6, 36. So those do add up to 36. So we've done a quick check. We know that we've answered the question. We will write a statement saying that. So the numbers are 11, 12, and 13. And we've solved that problem. Let's look at another one. This next word problem is a bit of a brain teaser. I love it because most people, when they look at it, are going to immediately give you an answer, and it's probably going to be wrong. So the question says, a man weighs 100 pounds plus half of his weight. What is his weight? And when I ask people that, they always immediately say, oh, 150 pounds. I'm going to show you how we can use algebra or word problems to actually find this without doing that guessing and in a more logical way. So in this case, it's his weight that we don't know, so that's what we're going to let our variable equal, and weight starts with W, so I'm going to use W. So let W equal the man's weight. In this case, we have a unit, pounds, so I'll just indicate that so I don't forget that when I express my result. It talks about half of his weight. We don't know what that is, so I'm just going to express half of his weight in terms of W. So half of his weight would be 1/2 or 0.5 times W. So that would be half of the man's weight. All right, it says a man weighs, so that another way of thinking of that is a man's weight is. So a man weighs or a man's weight is. So W, his weight, is 100 pounds plus half of his weight. So half of his weight would be 0.5 W. That's our relationship that was described in the problem. So let's just solve it. We have 1 W here and 0.5 here. This is smaller, so we're going to move this to this side by subtracting 0.5 W. So 1 minus 0.5 will give me 0.5 W is equal to 100. Now to solve for W, I'm going to divide by 0.5. That leaves me with W. 100 divided by 0.5 is 200. So I get 200 as my answer. Let's see if it makes sense. A man weighs 100 plus half of his weight. So half of that's 100. 100 plus 100 is 200. Most people are not going to get that right. Just if you don't believe me, try it. Ask your friends and family, see what answer you get. They probably won't say 200. I bet they'll say 150. So we finish the problem by making the statement, the man's weight is 200 pounds. Now I think that's enough for our very first video on word problems. I'm going to get into different types of word problems and the strategies I use for the different types. But for now, if you can find some questions that are similar to this where the relationship between the numbers is expressed right in the word problem, try it. If you're not sure if you know what those are and you just want to wait to watch some more videos, that's fine too. But remember, you do need to practice this to develop this.